Hi, Calculus 1 students. This is the second example of the section Limit at Infinity that deals with exponential functions. Before saying anything else, you should try this example first. So it's certainly in your reach. So if you haven't tried it yet, you should probably close this video and give it a try, and then come back to this video to compare what you did with what I did, right? So that we can so that you learn better this way. Okay, so first of all, before we tackle this limit, a recall. As x is approaching infinity, larger bases result in larger terms. And as x is approaching negative infinity, it's the opposite that's happening. Smaller bases result in larger terms. So in short, remember the technique is always the same when you deal with limits at infinity. It is to factor what's the largest. But for exponential functions, largest depends on if you're approaching infinity or negative infinity. So that's where you need to be careful. For negative infinity, you will factor out the smaller bases. And that's our case. Okay, so we are at negative infinity. So let's actually write this down. We want to factor the terms with the smallest bases. Terms with smallest bases. However, in this particular problem, you might argue that, well, what's the smallest base? Because they're all e's, okay? And my answer to this is not quite. You have to think a little bit out of the box here because the exponents are not the same, right? You have 2x, x, 4x, 2x. So let's actually look at let's have a look at the numerator. It will be more simple. Okay? So compare, let's say, compare e to the 2x with e to the x. Okay, so you would like to know what do you need to factor out, because for now they have the same basis. Okay, so what I mean by taking out of the box is you have to compare bases for the same exponent. So using the rules of exponent, you can write this as e squared to the power of x. You see? And then, but then e to the power of x. So, okay, here I'll write something that is never necessary, but it's just to give you the idea, right? Because the biggest base now is this one. So you see, this is why you need to think out of the box. So as you can see, e squared is bigger than e, meaning that e is the smallest base. So meaning e to the x has the smallest base, okay? So that's what I will say. So this is what you need to factor out. The smallest base. All right, so let's start over the problem. So let's write here the limit as x is approaching negative infinity of 3e to the 2x minus e to the x divided by e to the 4x plus 2e to the x. So what we discovered is that when the bases seem to be all the same, what's going to make a difference is the exponent. So the bigger is the exponent, the bigger is like the base associated with the exponential to the x. So this means that this is what you need to factor out at the top, and at the bottom, well, you have to imagine e to the power of 2 and e to the power of 4. These are your bases. In other words, that's what you factor out. So the first step in solving this limit is actually this. You will have the limit as x is approaching negative infinity of e to the x, okay? And then at the top, you just simplify, right? Using the rules of exponents. So here you will have 3e to the x minus 1 divided by an e to the 2x, okay? And then again, the leftovers. So using the rules of exponents, you will get e to the power of 2x plus 2. Okay. Now, in the case of exponentials, the reason why we actually factor the smallest base in the case of infinity is because remember that when x is approaching negative infinity, these will approach 0. So, okay, let's not skip steps because we still need to use the rules of exponents on that. So I'll write a step that is like not really extra, it's necessary. So what you get, and I will erase this 0 for now. Okay, so canceling the orange parts, what will happen is you will be left over with e to the x at the bottom. There you go. Yes, okay, that's perfect. Then we have 3e to the x minus 1. And then at the bottom here, you have e to the 2x plus 2. Now let's try direct substitution, okay? Now, as I said earlier, these will approach 0 as x is approaching infinity. This is a little bit more tricky, okay? Because in reality, it will approach 0 from above, and this will become important, okay? And how do we know it's approaching 0 from above? Well, it's an empirical fact. Remember, you sketch the exponential, you sketch like e to the x, okay? And this is what the curve looks like. This is e to the x. And what you're doing in order to figure out the orange limit is, again, you're approaching negative infinity here. And then as you can see, so by transposing the curve on the y-axis, as we typically do, that's it. So that this is so e to the x is approaching 0 from above as x is approaching negative infinity. So in other words, what we end up getting with direct substitution is this: negative 1 over 0 from above multiplied by 2. And the reason it's important is because you end up with an infinite limit, right? So you have to look for the overall sign, and seeing that the overall sign is negative, the answer is negative infinity. All right, I hope this video helped. See you in the next video or in the next class.